Like that, and creator experience. Yeah.
Así, empezamos en un minuto. 1 minute left.
Más sillas hay ahí. Si queréis más sillas, pues están delante. Ahí creo que hay dos.
Quita la etiqueta que se vea algo. Que de hecho no se veis dar en cámara. ¿Qué pasa, minuto?
¿Qué pasa, minuto? Vamos a empezar. Hoy lo vamos a hacer en inglés, porque Anton habla en inglés. Así que la charla va a ser en inglés. Y nos va a hablar sobre los módulos de Terraform, cómo organizar los módulos y tal. So, Anton, whenever you want, you can start with your presentation. So, go ahead.
Hola, ¿qué tal? Hablamos sobre Terraform y Codifying Infrastructure con Terraform, okay? And the rest in English. No, I think it will be much easier if we speak just English today, at least. So let's start. First of all, a couple, I don't know if you hear or if it's recorded properly. I'm a little bit sick today, so I cannot speak as loud as I want. But nevertheless, I've been working for several years with Terraform and AWS, and over the last 3 years, I was actively developing Terraform AWS modules. Oh, I can actually sit. Cool. So then we can sit here for the whole day or evening. So Terraform AWS modules is something what I got most of experience with. And during this talk, I will go through things which I learned and which I think will be beneficial for you as users of Terraform, and you will have to find something what is relevant for you and for your projects where you work. Other things which I contributed is pre-commit Terraform hooks to automatically format Terraform code and documentation. Last month I had some funny projects where I generate Terraform documentations as PDF, and also I made Terraform module TF, which is generating Terraform configuration code from visual diagrams. And actually, after I organize and speak at many meetups and conferences, I started writing Terraform best practices, because I see a lot of people struggling with them in very repetitive way. So I decided to just dump some of my brain into these text things, and here we go. I also write on medium.com, and you can always find me on Twitter or GitHub or chess.com if you prefer to talk about Terraform while playing chess with me. It also happened. So let's get started. I have about 120 slides. Some of them with animation, some of them are plain text, but if you fall asleep or if you have any questions, please make it loud so that I can answer, okay? Loud, not fall from table or chair if you fall asleep. So, Terraform modules, Terraform AWS modules is a collection of open source modules which were downloaded more than 2 million of times during last year. For things like VPC, autoscaling group, RDS, security groups, people tend to use these modules. And if you know what is it, can you please raise hand? Who knows what is it? Who's using this? Like, okay, so let's say 5, 7 people. Good. So thanks for that. And if you ever open issues or any pull requests, then again, I highly appreciate this contribution. And who of you actually use Terraform on daily life, like daily projects, for a very long time? Let's say 2, 3 years. Just okay, cool. So yeah, it's And who has never heard about Terraform or want to learn it? Like, is there anyone who has not used Terraform in production? Oh, cool. So yeah, about half of people. Right, so you should help me by narrowing this down. Who used or who did not use Terraform but used CloudFormation and want to use Terraform? I mean, I want to find question where just one person raised hand. Okay? Can you make this simple for me? Can you answer any of this question with just one hand? No? Still? Yeah, so what was your?
I've used a bit of confirmation,
Right.
but not like a full infrastructure, but for serverless,
Mm.
I've used a subset of confirmation.
You see, we found one guy who will get a prize. So, I know that it's not so cold here in Valencia, but this HashiCorp socks is for you. So you see, there are no CloudFormation socks, so that's why I gave Terraform socks to you. And also, there are some stickers on the tables which you can find. If there are no stickers, I have some more. So let's continue. Okay, so Terraform. Now we all, at least, or some of you know, some of you use it, some of you will use it because now he got socks. So Terraform is a tool which was started in 2014 in order to write, plan, and manage infrastructure as code. And this was the only goal for this tool. A typical main TF file where configuration is stored looks something like this, where declaration of variables is placed and configuration for resources is described. In this example, we are describing that we want to make S3 bucket, and that's all what this code is doing. So regions, resources, then we run some commands to download dependencies, and we run Terraform apply in order to see what is going to be created. And then at the end, we see that my bucket sysnail has been created. That's all a pipeline of, or this is a desired workflow with Terraform. You describe something in a file with extension .tf, and then you run Terraform init and Terraform apply to get this infrastructure created. So now, if you've been using AWS, you know that AWS has CloudFormation, and Google come up with something else. Azure also has Azure Resource Manager. And you may think that I'm good to go with just this tool and I will never need anything else. I mean, why on earth, if I'm using AWS, I will have to look into something else, like Terraform? And the answer is very straightforward. Is that Terraform support the same interface and the same declaration language for more than 100 providers. So using the same syntax and the same paradigm, you can describe resources in AWS as well as Google Cloud, New Relic, PagerDuty, logs, whatever else. And there are many, many custom providers developed by the community. So as soon as there is an API which can be called, then Terraform can be such tool to universally manage these resources. It can be even Jira issues if you want to create some Jira issues, or it can be New Relic metrics if you're using those. And there are many, many of them on official documentation. Actually, quite recently, yesterday, I was trying to manage Dropbox files using Terraform. It was possible, but it didn't work so nicely, so I gave up. But it is possible, as well as access and many crazy things which you historically used to automate somehow else. So let's begin. When project is small, everything fits into main TF file. You start with real stuff. So you want to make VPC. Of course, you declare it, but then your project grows. You start to add in a bunch of other resources. So you add in resources. You start to cover different regions. You maybe figure out that you need to integrate with other providers, like for DNS, or maybe you have some resources between AWS and Google Cloud, and so on. In this example, we are adding just one internet gateway. So we had VPC, and now we add internet gateway. and then we add some subnets, and then we have to add something else, and we need to output these values, and then we decide to add some NAT gateways, routes, routing tables, and so on. So we will eventually outgrow this file to many, many lines of code. So main TF will be growing like crazy. So it will be 10, 20 kilobytes of code, 300 lines of code. It's typical. And we are not even talking about setting up configuration for the application, which is probably giving you more value than network stack, at least for your company. So emerging issues starting to be visible is that code size is increasing and dependencies starting to be not so obvious. So a solution which HashiCorp and Terraform can propose to us is related to Terraform modules. So Terraform modules is just self-contained package of Terraform configurations that are managed as a group. There are a few types of modules which I really want to make clear, and when we're talking about modules, we have to, at least inside of us, understand what kind of module are we talking about. So it can be either resource module or something else. So resource module is something what just create resources in very flexible configuration. And they have no restrictions. They don't have to be tied to your company in any way. So that's why all of them can be open source with very good reason. So as an example, resource module can be an application load balancer or security group. So this specific code has or showing the way how resource module, which creates security group, is used. As you can see, we're invoking modules HTTPS 443 of specific version, which is hosted on the registry. And we are passing a bunch of arguments to it, like name, VPC ID, and so on. You may think, why I should be doing this if I can just use resource and create security group, right? Who think this is a good idea for security group? Like, why on earth you need module to create just one resource security group? So you think that making it as resource is enough, right? You don't need module for that. Right, so many people actually, I don't know, guys, you probably think that this is a joke, but majority of people think that this is a good idea to just make AWS security group module and make some rules into it. That's enough. In reality, resource itself cannot be versioned, but modules can. So you look at module as a single artifact, which has specific version, and you use just specific version of it. More code, if you look into this code, this is a real implementation of security group module. It is more than this. This is the real code of security group module. And why it is so complicated, why about 300 something lines are necessary to create security group module, is the main answer for that is that HCL and Terraform 0.11 does not give us all the flexibility which we need. That's why we need to use extensively count operator or count argument in the resource block in order to define whether we have to create this resource or not. So that's why when we are saying to someone, hey, please make security group, and he will just make security group. He will just make it work for one subset of all features which security group can support. To make it clear, security group can be created for prefix list, VPC endpoints, IPv4, IPv6, has self-reference, and few other things. Many of these arguments are self-exclusive, so you cannot have self-reference as well as IPv6 in one block. That's why all of these 300 lines are necessary to make it supportable. If you look into this code is open source as well as all other code which I'm going to show here. You will see why it is implemented this way. So another type of modules is infrastructure module. It already consists of resource modules which we saw previously, and it also enforces some tags and some names and some security restrictions which your company imply or your industry imply. So this is a good place for your company to benefit and to actually use some sort of preprocessor or some JSONet cookie cutter. I will show some of this later. The point is that you take building blocks which are resource module and make something what your company is gonna to be using internally. For example, your company will have to spin up ECS services behind load balancer. So you have to pick up existing modules or existing resources and combine them somehow. So this somehow is called infrastructure modules. As this example, module for Atlantis looks very similar. So we are specifying that we want to get this module Atlantis, and we pass a bunch of arguments into it for VPC, for DNS, and for the application itself. Internally of this module, we have an invocation of different modules for VPC, ALB, security group, and so on. So types of modules, resource modules, Terraform, AWS modules, and infrastructure module. That's two types of module. Usually people think about Terraform modules as one type. I kind of disagree with it, and I try to make people life a little bit easier by making or by hiding complexity, as I showed on security group module, inside of resource modules. So if you say that you need to create something, you have to use existing modules in order to not become an expert in Terraform. If you want to become an expert, welcome, I'm hiring as well. But for free, since everything is for free. So let's look into how to write modules and how to call them and how to work with code. So far it was basics, and let's go a little bit deeper. So tip number 0, actually, when we want to, when we look into our current tasks and we think like, oh yeah, that's exactly great use case for my resource module, I will go and write it. So please don't do this, because most likely there are people who did this already, did it successfully, they open source this code. For AWS alone, there are more than 600 modules available right now, just in the registry. Plus, many, many more people don't know about registry existence at all. So actually, that's a good question. Who knows what is registry? Okay, who doesn't know what is registry? Can you raise? Oh, I don't have so many socks. Sorry, guys. No, but yeah, that's actually a little bit disappointing. Is that registry is a collection of common infrastructure blocks which other people develop, and they committed there. So they integrated their GitHub repository with registry, which means that every time you push new version, it will be automatically updated, and other people can reference to it, which is a very nice way of discovering existing modules. So high quality modules are usually there or behind firewall. But resource modules are usually there. So I encourage to check this registry.terraform.io for many, many things. And I'm quite certain that many of you will discover solutions for your existing problem which you think you are the first one to solve. It happens quite often.
But how reliable are the modules there? I mean, I have some experience with a configuration management system that they say they have formulas. Well, everyone here, I think, has some experience to some extent with configuration management. So maybe you go to use some sort of modules, or what I think are, yeah. And for example, we found that maybe some of them are not as reliable or as maintained as you would need to make it to make use of it in production.
Yeah,
so you say 600. If I
600 something. Yeah.
Yeah, around. So I think that's a lot of code to maintain, and I know there's a huge community.
Yeah. So that's exactly a type of question which many people were afraid when the announcement of registry happened last year. And that's exactly what we were trying to prevent from happening. So some of these modules have this sign which guarantee that maintainer, in this case it's me, who are verifying this and maintaining them and updating them and fixing bugs in predictable way and so on. So this kind of things is guaranteed by HashiCorp and by me.
Ah, okay.
In majority of situations, there are no such guarantees. So you have to you have several ways. What many companies are trying to do is that, like when I talk to big companies and I say, "Hey guys, why don't you use code?" Which I say, they say, "We looked at your code for inspiration." But I said, like, yeah, but I'm maintaining it for last many years and lots of people are using it. No, we are like enterprise, we cannot use it. We looked, we delete everything what we didn't understand, but we got it for the inspiration. This is pretty famous pattern. I mean, I don't have any objections about it. The only downside is that they don't contribute back. So if it is on GitHub, since all of this is public, sometimes people fork it, make their own cool thing, and they don't care about giving it back. So I have to go back to their repositories and send pull requests to myself. So this, yeah, that's absolutely typical. But the problem with trust exists here as well as in Puppet Forge or Ansible Galaxy. Yeah, this problem exists forever. I hoped, or I personally believe, that this will be fixed in approximately summertime with some sort of automatic verification. So there are some mechanism to identify whether the code there satisfies some criteria. Let's say well-formatted, existing documentation, has examples. I will show some of this list later on. But as soon as it will be executed automatically, you will be able to see some number 9.5 out of 10, which will give you at least some understanding. I now understand there are few companies who are providing high quality content inside of this registry, and they don't have this verified label. But still, I know them personally, so I use their code very often. So, yeah.
And does HashiCorp have any rules or make you check anything to put that point, that blue dot there in your module?
Since it's recorded, I cannot answer, but no, the point is that there are no such official list of things which you think, oh, I made awesome module, I will just adjust it to make it look nice and everything will be fine. In theory, that should happen, but in reality, it doesn't happen for the last about half year. Mm-hmm. So I contributed some modules which I personally think they're the same quality as other, but they were not approved because there are some ongoing process going on related to Terraform 0.12 and a few other things. So, but just stay tuned, and at least this should be able, like this is a good starting point for you to go there and type Kinesis, and then you will see 20 modules and click on each of them, and just by checking README, you will understand whether person actually thought carefully about different use cases, or he just implemented his small subset of Kinesis features and he doesn't care about the rest.
Yeah. Also a good way to know if it's in shape or not, it's checking if the maintainer is actually contributing, or the last comment when it was, and stuff like that, because if you check a module and the last comment was 2 years ago, then you know maybe you should check something else.
Yeah, but for inspiration, you should be able to get good picture. Okay, let's get going. So another tip which I have is hide implementation details, which means that if you if you're a user of Terraform for some time, you get used to hacks like using count, using conditional, different looping mechanism, and so on. But you don't want your users of your modules to be expert on the same level as you. You want them to operate on their scope. They say, oh, I need a relational database service. Cool, what type of database you need? They say, oh, I need MySQL, cool. Or they say MS SQL. If they say MS SQL, then inside of your code, as we can see here on line 7 and 12, we're actually creating two databases conditionally. We either create an MS SQL database or we create a MySQL database or Postgres or whatever else. This is needed as a workaround because MS SQL can support time zone while nothing else can. So that's a workaround which you don't want your users to be familiar with. So hide all of these details for them. They will be much happier. And as an output of this module, you output the first value which is not empty. And again, they don't know that you created one resource or another resource for them. Module hide all of this for you or for them. Second point is size. If you have your infrastructure module inside, so you have your infrastructure repository which consists of many small modules like the one to create IAM user or some other small subset of resources. You don't want every time when someone is using this module, you don't want them to download the whole repository and then just check out a small directory in that one. The solution for this problem is to either clone the whole repository before referencing folders, or you can use tool like MBT to build small zip archive for specific Terraform module and let users use just this one. The benefit of this solution is that every time Terraform will download just 1 or 2 kilobyte archive instead of several megabytes. And if you do creation of IAM users in a loop, it will mean that it will not have to download the whole repository every time you want to create user. So I encourage to check this project MBT, which is quite nice for this purpose. Couple things about avoiding in module. So if you specify provider and you specify assume role there, it means that the problem with this one is that if there are two users, one is called Vasya and second called Petya, and they configure their environment to access differently. Let's say Petya is using default credentials mechanism and Vasya is using default credentials mechanism and Petya is using shared credentials file. In this case, they will not be able to use this module. And this is one of the most popular problems in modules which you discover in the community created by people who just made it to work for just their use case. They just never thought about this. I mean, what can possibly go wrong? The same goes if provider version is restricted inside the repository. Then again, you cannot override provider block outside when you use this module. So it means I cannot use this module. And so on. Many problems are related to provider block being placed very deeply inside of your module. And provisioner is also evil. In particular, this part is evil. So local exec will be executed on the machine where Terraform apply is executed once resource is created. So I really recommend to not use this one for anything. And also it's bad idea, I will show why. Also it's bad idea to use local exec even on AWS instance, which means once instance is started, let's run Ansible playbook, connect to that instance and do whatever we want. This happens, some people say that no, but in fact this happens so often because people think like I'm the only person who will ever execute this code, but it's bad idea so it's very hard to reuse and very hard to extend later on. So one solution is to use cloud-specific features like user data, where you can specify what kind of stuff you want to happen from this instance once instance is started. But another reason for doing that is that if you start using provisioners and you chain all of your provisioner like one by one, you use combination of local exec, remote exec, you call Ansible playbook, you call AWS CLI, and you do everything, and everything is fine. Then you decide to replace AWS instance with launch configuration. Launch configuration will be created not on your machine. It will be created on AWS. And you don't have a way to execute local exec while AWS auto-scaling group will be spinning or scaling up or down. That's not controlled like this. So that's why user data is the only way to do that. If you want to use null resource, if you want to use provisioner to execute something when resource is created, the recommended approach is to use null resource for that. Null resource is actually null resource. It doesn't create anything. So the beauty of it is that it's not a physical resource which will be deleted. It means that provisioner will be executed when it's created, but no physical resource is attached to it. It will be, in this example, it will be executed after AWS VPC is created. A few traits of good Terraform modules in order as I see them. So first of all, the most valuable information is in documentation and in examples. Documentation shows how much developer actually thought about use cases, what kind of solutions he was trying to cover with this module, why he was doing this. So that's very helpful information for you to decide whether it's something for me or maybe my case is not even considered, and so on. And examples show you exactly a piece of code which you can just copy paste and adjust for your needs. I would say huge amount of modules does not pay enough attention to this. But this actually sorts out something what you can use or should use from something what nobody was actually thinking about. And also how many or how much features covered in this module, which means does this module support all arguments or all attributes are exposed from it? Because if it doesn't, then I cannot use it. I will have to fork it. I will have to do something about it, which is bad. And same defaults is also relevant if you think that I'm going to open source module and I will hard code count to 5. Thank you, but I need 6. And somebody else need -1. So again, we don't need to override something what should not be specified in first place. So make it obvious for people to fail if they start using it, and it will tell, hey, by the way, I need to have this specified. Cool, then I will at least know and I will provide it immediately. But don't make me go into variables TF and think about why here is 5. Maybe it has to be some crazy formula. So yeah, just keep defaults usually to empty string or 0. It depends on situations, but make it really sane, not opinionated. Clean code means that the code in the module should not create any resources just for fun, just because I didn't have other place to put them, so I will create it here. Again, for your situations it may be good, but it's not something what will make this module actually usable by many other people. And this is one of the reasons why people look into code and they think like it's good code, but I don't need this IAM role, this instance profile, and by the way, why this S3 bucket is created here. So it's much easier for them to just delete everything and just copy paste 10% of this. It happens also quite often when people didn't think like initially what this module will be doing, but just add organically. I need this stuff, I will plug it in. Oh, I need another stuff, I will plug it in. Then module just explode. And I put on the last slide or last point here tests, which means that I honestly don't believe in testing of Terraform modules as is. And I will show some of this later, but what I just want to tell now is that tests are very different between who is actually using these modules and in which combination. It's good that you verify that Terraform code is valid, plan, pass, that's enough. Really, it's impossible to predict where this module will be used, in which combination, for which parameters, which region, when AWS account was open, whether you have classic link on VPC enabled ever or not. All of this will be different. That's why there are some edge cases, which means it's not possible to add IPv6 into VPC module, because if you use this module on region where IPv6 was since very beginning, like Frankfurt, there was no release with IPv4 and then v6. So they have different API signature and not many things will work. But if you use it for EU West 1, which exists for a very long time, then it will give you another output. I face this limitation myself because I always use, or not always, usually I use EU West 1 in Ireland, and it looks good. But then I pushed this code with IPv6 support, and I was so happy and so proud. And then the guy said like, oh yeah, it doesn't work in Frankfurt. I said, oh yeah, good to know. So I reverted back, and since that time there are no support for IPv6. But this module had IPv6 support for a couple hours. So yeah. So if you can, don't write modules. Check for inspiration different places, and avoid providers and provisioners. I honestly believe that provisioners will be deprecated at some point in Terraform, and there are better ways to, or better places to put your configuration management logic outside of infrastructure. So your infrastructure is created, and then your Ansible playbook, whatever else, is running outside. You can trigger them if you really need, but not for all situations. So let's look into how to call modules, because yeah, there are a lot of more slides. So when we are imagine the situation, the amount of resource and code keeps growing, and let's look into how to organize code. So one of pattern here is, as I call it, all-in-one, is where we have small amount of files or large amount of files, as I saw recently, main.tf, and in this place where we are invoking a bunch of modules. So we invoke, in this example, we're invoking VPC, ALB, we are creating an application, we're creating a bunch of security groups, bunch of microservices module. So all of this is called in one big go. So quite obviously you will soon discover that execution takes time because everything is blocked at once. So every time when you run Terraform apply, the Terraform refresh will take some time to figure out whether this has to be changed, whether graph has to be rebuilt, and so on. So the blast radius is pretty high. By changing some values in one place, you may have a lot of very unpredictable changes in many other places. So that's bad. But what is good is that you have to declare variables and outputs in a few places, because all of them are in one folder. You don't have to copy paste. Another pattern, which is on another side of it, is one-in-one, where you have very small or smaller blast radius, and you have to kind of have a possibility to connect invocation. Let's say now I work in VPC, then I work in application load balancer, and then I work in application. So yes, and the scope will be smaller, but you will have to also declare variables in many places, which is output variables TF will be pretty much repetitive, which means that variables in one folder will most likely be correlated with outputs in another files. But in reality, it is easier and faster to work with, because you are seldom going to change things in all of them at once. Usually you work you do very little work in long time environments or long time places like VPC. So your VPC will not be changing daily, while your application may be changing every now and then. So can you guys tell, like, you can just imagine the code which you have at work, and who's actually having like all-in-one, where you have TF files which involve a bunch of modules. And when you run Terraform apply, you run it. You run across the whole project for the whole environment. Nobody. You're lying. Come on. I saw some code today. Okay, so no one.
No,
Okay, so you can raise your hand. Okay, good. So, and who is using one-in-one, where the separation? Yeah, so 2-3 people. I mean,
we also.
yeah, right. Yeah, I know. So anyway, more people are using one-in-one, which is actually similar to MFA. MFA is somewhere in between, because in many situations, when you start working on a project, you're not thinking that, oh my God, that's going to be an awesome project. I will make everything perfect. Everything will be just like awesome. I mean, I will just kill everyone. It's just the best of the best. So you start with main TF. You put lots of files, lots of resources, modules. You evolve over time, right? You cannot start with small things here, small things there, and then somehow figure out how to correlate them together. So you usually start with, for small things, you start with main TF and you put things up to 10, 20 resources in one, and then you figure out how to decouple it. So the thing is that there are situations when you actually need to have small things in one. And what kind of orchestrations tool do you use? Like makefile to call Terraform init here and then Terraform apply. So makefile is one way. Another way is that if you would use one big all-in-one solution, then you don't want to change everything at once. You just want to calculate minus target and specify that I want to do changes in just this module. So you can specify minus target equal module dot something. So this you can do. What other ways of orchestration or tools for orchestration do you use? Yeah. To call Terraform using Terraform module in Ansible. Yeah, it's good. I think you're like first person who actually used this module. Good.
Actually, I believe.
Sorry?
No. I believe CubeSpray does it.
Who?
CubeSpray calls Terraform Ansible.
I don't know.
At the end, it's a command just calling it's a wrapper over that. It's the same that the main file.
Yeah. So there is a way to make orchestration in Terraform. As I showed earlier, null resource can be used to call Terraform apply with target. Who likes this way?
It's weird.
Come on.
Feels weird.
At least one person believed in this joke. No, I mean really, you can certainly do crazy things in Terraform by calling Terraform and do lots of crazy things. But Terraform was not designed for that. Believe me, I tried to struggle with Terraform developers for several years, telling them different edge cases, how Terraform can be used or abused. And this is one of these, when I showed this to them, they say like, no, it cannot be done. I mean, you don't have to do this. I know that I cannot, but I mean I can, but I really should not be doing this. So Terraform is just a tool in order to write something, plan something, run it. That's all. In order to make an orchestration, there are tools like TerraGrant, where you can actually specify which modules do I have. Well, I have network and I have EC2 instance. Cool. So let's make these two dependencies talk to each other. So typical TerraGrant configuration looks like this. We define what kind of module we want. We want EC2 instance of this specific version 1. And what kind of dependencies it has. It has dependencies to network, which means if there is no network, there is no way to make instance. Cool. And what kind of properties it has. It has name, AMI, instance type. Cool. So that's the beauty of it. Again, in this example, we did not declare any variables, any outputs, and we just specify which module with which arguments we want to make. That's all. The only problem with TFVARs, as I see, is that it cannot contain dynamic values, which means that if my network stack has been rebuilt, I have to go to EC2 instance and say now that, hey, by the way, use this subnet ID. I don't want to do this, really, so I fix it. And the way I fix it is that I made shell script, which actually changed these values in TFVARs file. So yeah, you can find this on modules TF repository. So all it does is just, okay, I can show later. So all it does is that when you run Terragrant apply, it will look into dependencies and it will see, oh, you're referencing to subnet IDs, for example. And it will go to the folder where subnet IDs should be picked from. And it will just get those IDs and paste into this TFVARs file for you. So it will automatically update this for you every time when you do some changes in any dependencies, it will just populate new changes. And it does it transparently using Terragrant hooks. So you don't have to change it every time, or you don't have to remember it to update in one place or in another. So let's summarize this chapter. So all-in-one in general works better over time, and orchestration is not Terraform but Terragrant, and dynamic values in TFVARs exist with hacks. And there are no intention from Terraform to make it as a feature of Terraform, just to make it clear. One way how you can do this is that you can actually do or you have to compute these values in runtime and pass it as variables as CLI argument. So you can write Terraform apply minus var and then subnet IDs, and then you can actually put subnet IDs in runtime to it. But this diminishes the whole purpose of TFVARs file, which already contains 99% of configuration anyway. Why I should provide non-sensitive information in CLI. So yeah, if you know any better solution than this shell script, please tell me, because I use it everywhere now, and I don't see any better way to replace it. So yeah, I'm looking forward to hear from that. So let's look into how to work with the code. When we have to add new feature, obviously it's easy. But when we have to create new or existing, imagine the situation when you have an infrastructure module which has to be smart enough to accept VPC or create VPC. So if you have module where VPC ID is provided, then try to find this VPC and put resources there. If there is no such thing, then please make this one. This module, or these two blocks, data source and resource, can be used together, and count is different here. And again, as output, VPC ID is specified. It will return first not empty element from the list, which in this case will be either existing VPC or newly created VPC. This pattern is very powerful if you want to make your module to be pluggable in different situations. Sometimes you need to create new security group if it was not created, or sometimes you need to ask user to provide security group, for example. And working with list. Yeah.
In which cases is that required? Because by default Terraform is usually checking whether that resource is previously existing. If it exists, it's not creating it. So why something like this will be required on top of what Terraform is doing?
So Terraform will check if a resource is required only if it was previously created in the same configuration. If let's say I have infrastructure shared with different type of people or different projects, I don't know which security group I should be using. So that's why I'm asking users for input. They can tell me. But if they don't tell me, then I will make default one and use it. So you're right that it will use and it will refresh Terraform TF state file if it previously knew about this resource in this specific configuration. So working with lists in Terraform 0.11 is not so easy. In particular, it's not so easy or it is easy, if you can allow to recreate objects. In this example, Terraform TFR's file contains list of users, user 1, 2, 3, and 4. And we are creating several files for them. Let's say these are going to be public keys for these people, which we host on S3 bucket. Quite popular example. So what's going to happen? We're going to create 4 objects, 4 files in S3 bucket for user 1, 2, 3, and 4. That's fine. Then imagine a situation that user 3 is going to be removed. So we remove him. And the way how Terraform 0.11 works is that it will delete user 4, and since his index is changed, it will put user 4 on place of user 3. So that's why after deletion of user 3, user 4 will be recreated. Okay, so for files which are not gonna to be new every time, it's totally fine. We can allow recreation, or we can it will be just fine because this will be recreated with the same content. Yeah. So this is called stateless list. Another similar example is when we have stateful list. Stateful list is a list which will be having different values every time when something is created. So imagine that we need to manage IAM access keys for these users, and we cannot simply allow to delete user 4 and then recreate it. This means that user 4 will get new access key every time. So every time when somebody with like user 3 is leaving project, then user 4 will be suffering and he will have new access key. That's not acceptable. So the solution for that, which many people are using, is JSON-net. So imagine the structure as here is JSON file where we declare username and key base. And this is how JSON-net template looks like. So we are importing the user's configuration, and we are creating JSON structure from this. JSON-net is data templating language by Google, which is quite popular to fulfill or to automatically generate JSON files from data structures. So when we have some strange data and we have to go in a loop and create another strange data, that's exactly what we need for this case. So the output from this template, now gentleman took picture, will be like this. So we run JSON-net and we execute this template and we output into tf.json. And by the way, files with tf.json will be treated by Terraform natively. So Terraform works with HCL and with JSON transparently. You can mix and match these two files, two formats, same way. It's just fine. And output will look like this. So user CF.json will create several modules. So one for each of these user, and it will be invoking each of these source independently. So the benefit of this one is that it will be creating just separated modules for each of these. In reality, it means that if we delete user 3 from this list, no other users will be affected. So if we need to have an integration between different pieces of code, it can be helpful to output the entire command as is. For example, if we need to execute this command later on, we can just dump it from the module, and then we can execute it like this by getting from Terraform output, which is very handy if you need to fulfill, again, missing gaps or missing resources, missing features of Terraform provider. So when we have to, sometimes we may need to execute these things which we get from here. We just want it to get executed automatically on our machine. So we use null resource and we combine it with local exec to actually execute and provide real values. So this is one of the way of adding majority of functionality which is not currently available in Terraform, but you really want to use Terraform. This example here with WAF regional was used, I don't remember when, but it was used for quite a long time because WAF or Web Application Firewall in AWS existed for quite some time, but not with all features. So we use it for everything, but for features which we still needed, we used to execute AWS CLI because CLI had everything. Edge cases which are related to previously, as I said, testing, different AWS region, different signature, IPv6 support, date of creation accounts, all of this will different between where Terraform is executed. And also services and features availability is different between regions. So that's why I have put testing on such low priority. Few things to avoid in Terraform in general is if it is not secret arguments, just put it into TF-vars. Don't make anyone in your company to remember what kind of -var or -var file arguments they have to put and in which order. And especially if there are more than one, believe me, there will be a chance that somebody sometime will forget it or will put another one and it will be just fuck up. If you want to prevent it, put everything into TF-vars and it will be much easier. Same, try to avoid targets and parallelism in order to work on not all infrastructure but on subset of it. It's much easier to just split this thing into smaller pieces already. Terraform Workspaces is evil, and I believe that separation by directories is easier. Let me explain, because I have actually changed my mind quite recently, and not totally opposite, but more towards that it's evil. So previously I thought that no, it's not so evil, maybe there are some use cases, maybe some people know more than me. In fact, documentation was bad. Now when documentation is updated approximately 3 weeks ago, it started to be clear for absolutely everyone who read it just during the last 3 weeks. Let me clarify it a little bit more. Terraform Workspaces is a concept of separating Terraform it's a way of executing Terraform configuration with slightly different modifications per workspace. So you may have previously on examples and in documentation it was that you can use workspace as an example was dev and prod, and recently it was changed into something else. The point is that dev and prod are long-term environments. They will most likely have a lot of differences, not just in values but in other properties as well. Maybe some services simply don't need to exist. Maybe in dev you have VPN, but in production you don't have VPN. So there can be many big changes. And if you put workspace in condition or in count, which is even worse, then you make your configuration very hard to understand what is going on. And then you actually break in the core principle of infrastructure as code, which is that you have to be able to answer, and without any brain cycles, you have to understand what kind of configuration has been deployed, in which environment, by whom, when, and so on. Everything is transparent in the code. When you embed some crazy values like count and workspace name or comparison, then you make it not so obvious for people to identify what kind of configuration has been deployed. So Terraform Workspaces can be used for just short-term environment which are synonym of feature branch. Something what will eventually be killed and you will not be angry about it. But always separate by directories stuff like production stage and development, but feature 1, feature 2, feature 3 can be an environment within stage and environment, for example. So that's an important addition, I would say. So Terraform Workspace is not so bad for just something what is fine, I will kill it tomorrow, or fine if I kill it, or I create it when pull request is open. Yeah.
So exactly this is the use case for wrappers like Terraform, right?
Yeah.
So you can manage different environments having smaller pieces of code.
Yeah, that's similar to what I'm kind of thinking as well. Is that Terraform allows you to use module and separate it by directories and enforce this reusability of the code. But what Terraform is not able to do is taking into account workspaces. Workspaces is something what currently does not have to have configuration. So workspace is like, think about this, is that you have account staging, and you, or development, just to simplify things, you have development account. You have configuration for your development account. By default, you work in workspace, which is called default. But you started new feature branch. So you open pull request, you made some changes, and where this infrastructure has to be deployed. Fine, it can be deployed in workspace, which is matching your Git branch name. But once this feature is merged, it will be safely deleted. Because feature is merged, so it means now it's part of dev. I don't need this environment. And Terraform does not have enough kind of CLI, enough, how to say, reflection in the code, so that I cannot see what kind of workspaces do we have at all. So this transparency is a huge problem for, like, this is one of argument when I hear from people who say, yeah, we have built our dev stage test in production from one folder using workspaces. Then I can ask question like, is there any guarantee that there is no environment which is called staging 25? Like, there are no representation of it in the code, but and also, what kind of version of staging environment did you deploy? You cannot answer these kind of questions just by looking into the code. You have to do some Terraform workspace, select this environment, Terraform show to show state file. So you have to do a lot of operations in order to get information out of it. So that's why for just feature branches which are short-lived, it's okay. But for anything what is more or less permanent, like dev stage and prod, making more files, making it very easy to find just by looking up in directories is very important. And dependency hell in modules. Usually you don't need to have module in module in module, simply because it can be supported. Most likely you need to think about this as pragmatic as possible, and don't try to reuse your code just because there is a way to reuse this resource. So as an example can be you create let's say security group in one place, and you say that, oh no, from now on I will use this single resource everywhere in my code. Maybe for some situations it's overkill, and believe me, in most situations it's overkill. So don't try to use module in module in module, but just use one infrastructure module which consists of your resource module, and that's it. There are no need to go deeper. Very seldom there are use cases, let's say, to generate JSON of specific way. Then you have to use just as a wrapper, for example, to generate JSON as or ECS task definition JSON. You may use some module for that. So let's look into list in Terraform 0.11. Yes, they can be painful, and yes, perceive Terraform easy means that don't try to use all features of Terraform CLI simply because they are documented. Try to always write code which you will be always able to execute with just init, plan, apply. or destroy. But don't remember all these flags, var file. Try to make it as explicit as possible in the code itself. Make more files, make it more logical for your situations, for your cloud provider, separated by regions, by environments. Really, you will give yourself much better life very soon. So yeah, actually in the title there was for the future. So what do I mean by that? The Terraform 0.12 is coming up soon. Does anyone follow this close enough? No. So some of you follow, I guess. So Terraform 0.12 is one of the biggest release, or actually it's the biggest release ever in Terraform history. New syntax is introduced, we don't have to write double quotes, dollar, curly brackets for expressions anymore, and few other syntax sugar. There is support for loops, support for dynamic blocks, correct conditional operations where left and right parts are executed not at the same time, extended type for variables, so you can specify a list of maps of list of maps, list of maps of maps of list if you want. There are many features which, if you're coming from developer background, you may think that that's exactly what I need, I couldn't live without it. And templates in values, so you can really do crazy things. If you come from Ansible, then you will actually think that, oh my god, now I can make everything as YAML and make everything unreadable. Yes, you can. So Terraform 0.12 is tool for you. And there will be support for linking between modules, so output of one will be possible to be argument in another module, and Terraform will respect it. This means that it will be possible to use computed values in count, which is really one of the hottest requests from people. Many people ask for it, and much more of this in more details is on this link. It was published I think about summertime, and a lot of people expected that Terraform will be released like really soon. In fact, it was the plan that it will be released pretty soon, but over time, or approximately around November or October, it was pretty clear that it will not happen so soon, because Terraform HCL or HCL previously was consisting from several pieces, or from several technologies. It was language for HashiCorp configuration language, and it was HashiCorp interpolation language. So these two things are pretty different, which means that interpolation and syntax was one thing, and it was very hard to maintain. And this means that a lot of time was spent, and still going on, to make sure that this release is going to be backward compatible with your existing infrastructure. This is really important to not lose all existing customers. So that's why this release took some time. This release is still not going. As a summary, there will be several summaries, believe me, I'm not finishing. So as a first part of summary, I want to tell that I really encourage you to write less and simple. Write more files, but make them as granular as possible. Split this into a way which fits your company, your project, your needs inside of your organization. Don't try to make one big thing and somehow figure out that Terraform 0.12 has all of these for loops, all of these conditions, so I will make my own stuff now and Terraform 0.12 will fix it. I've heard this feedback from people who think that 0.12 is what they need. So no, it will not fix your code, and it will actually give, if you think that Terraform 0.12 has all of these features which I will be needing quite soon. In fact, no, you don't need any of these features right now, and you will not need them. And the reason why I'm saying this is that I believe in abstraction between who are you writing this Terraform code for? Who are your users? If your users are just application developers who are happy with just Ruby, Java, whatever else, then that's fine. they don't want to learn Terraform just because you force them. They will be happy with just using what module you give to them and provide key values to it. That's enough for them. You don't have to load them with all of these dynamic blocks and for loops. It's good to hide from them. Again, hide complexity from users inside of these modules, but your users will not have to know what is inside of it. So I'm quite certain some people, including young gentleman who is moving or migrating to us from CloudFormation, may have wondering why Terraform and not CloudFormation if I'm going to always use just CloudFormation, right? So yes, as I said earlier, you have support for more than 100 providers. It has easy HCL syntax, and it's one of these tools which allows to have high-level abstractions of infrastructure. In CloudFormation, you can also achieve some of this, but as you probably imagine, it's a little bit harder to do. There are no concept of modules. There are nested stacks. You can do many things similarly, but I believe that it's easier to use and faster to develop with Terraform. I'm not going to read this slide, but I guess all of you read this. So this is most interesting. I know now everyone will take photo of this, but while people are taking photo, I can go through some of this. So handling secrets in Terraform is not so obvious, right? If you come from like any not infrastructure related tooling, you think that, oh my god, secret is so sensitive, so of course HashiCorp thought about this, like, and solved this for me. No, nobody solved it for you, really. That's not the way how it is. One of the reasons why it has not been solved is related with the way how HCL has been designed. So HCL, as I said earlier, HCL and HashiCorp configuration language and interpolation language, they are now together, or they were together. Now they will be different things. This means that if you use secret somewhere, we know that this is secrets because you reference to it. This means that if you specify, if you point to this secret somewhere in other resources, in output or in input in other place, we know that it has to be encrypted. Then it will be encrypted everywhere in this chain. Previously, if it was one language, we could not know where this secret will be used. This means that what exactly we should encrypt. Should we encrypt everything because you use secrets? Maybe that's a little bit too much, but that's what TerraHelp is doing. So nevertheless, AWS, since this is what I'm working with for the last many years, I have figured out these solutions. So if you're using IAM and access keys, you can use PGP from Keybase to encrypt it, and it will be stored encrypted in TF state file, and only users PGP key will be able to decrypt it. This is pretty safe way of distributing access keys for all employees in a company. And for RDS, there are two ways. One is to set dummy password and change it after it's created, again using null resource and local exec provider. And another one is to use IAM database authentication enabled, which is not supported for all database types. Yeah, instance user data, KMS, secret manager, systems manager, Chamber, or any other tool, it will help you with this quite significantly. Also, secure remote state location, S3 bucket policy, KMS key is essential. That's no-brainer. Terraform 0.10 or 11, I don't remember, has changed the way how it works with state file. So right now, if you write Terraform apply, and you have state file remotely, it will download state file only for the usage in memory. It will not persist the state file anywhere on the disk, only if it crashes sometimes. But in general, it will be in the memory, which means that your secrets are more or less safe. It will be encrypted at rest and in transit as well. So yeah.
Are you aware of any initiative or a tool that can check this kind of compliance checks on your Terraform files?
Yeah, I think. Yeah. So the question, I don't know if this microphone actually a repeat question. So I will repeat. So the question is there is any tool which can look into TF state file and tell that you are using something unencrypted? And the answer is no, there is no such tool out of the box, because what is secret, really? I mean, maybe a username is secret. So there is no principle, like Terraform and Terraform providers does not know what exactly is secret. Some outputs may have sensitive equal true in outputs. Does not mean that this is actually secret. It just means that it has to be not printed in output, but it will be still persisted in state file as normal. And the way you can do this is that there are some tools which you can execute yourself. Since TF state file is JSON file, you will have to run your Terraform apply, check the state file, and see if you are referencing to some resources like AWS access key. Then it is secret. But again, this secret may be encrypted already, and for you it will be hard to identify if it is encrypted or if it's real. I mean, you can guess by lengths, but it's probably unscalable. Yeah.
Will this behavior continue in 0.12?
As far as I understand, this will be starting to change approximately 0.12.3, 4, something like this. Right now, everything is towards getting this out of the door, and at least it will be possible to do. Because now, as I said, in HCL1, it is not possible to track where secrets is used. So what we should encrypt? TerraHelp solution encrypts everything. So you just encrypt all TF state file for you. I mean, I have no clue what is there, so I'll just encrypt everything. It works. Yeah, people in OpenCred use it for quite some time. AWS has pretty good tooling around it, as you can see. If you look into what other providers have, they don't have so much. So there are some initiatives by people who are using like OpenStack and they still have secrets. There are some, I would say, strange solutions. Like if you have secrets and you have to use it, then you don't keep it in Terraform. Like really, you create resource and you change it outside of it. On OpenStack, some resources can be connected like this. So you create something with password dummy, and then connect with dummy, change it to something what you track outside. So if bad guy get access to the state file, he will get access to bad password. There are a bunch of tools out there. Some of these I mentioned. Terraform registry, which is this, and Terraform linter is a tool which is pretty helpful for post Terraform plan phase. Terraform plan will just execute or will calculate what is going to happen, but it will not guarantee that this is actually going to happen, because maybe you don't have enough IP addresses, maybe you specified wrong AMI ID which you don't have access to. And TF-lint has possibility to extend this with your own rules so that you can execute TF-lint after Terraform plan, and it will just tell you that AMI ID is invalid or instance type is not there, and so on. And you can exchange it. You can add some of your rules. But it happens like before applying it, which is catching some of information, but not all of problems which will actually happen in plan or in apply phase. So Terraform apply is the only command which will identify that something was totally wrong, and no testing will help you with it like TF-lint. TFN yeah, if you're a visual guy, Terraboard can show you something. It is just a visual web dashboard which will be able to show you Terraform state. When I asked some of people who use Terraform for big stuff to try it, they say it crashed. So yeah, I don't know how it's possible to crash. It's Angular, so it, yeah.
How big was the project? So, I mean,
I don't know.
100.
I think it was about 200 resources. I mean, yeah, maybe they put everything like in one state file, and then state file will grow several, I don't know, megabytes or 20 megabytes. I don't know. So again, it makes sense to work with smaller things to not crash these kind of tools. So and JSON.NET is going to be there because if you know what is KSON.NET, well, this is better than JSON.NET. So KSON.NET is Kubernetes implementation of JSON.NET, and this is JSON.NET. So similar stuff, also by Google.
It is discontinued by
Exactly. So yeah, it was discontinued during talk we attended. You was there as well?
No, I wasn't there.
So it was, I was in configuration management camp 3 weeks ago, and the guy was presenting and telling that, hey, we're using this awesome project, KSON.NET, and then somebody shouted from the audience that, hey, it was discontinued half hour ago. And he was telling like, yeah, we believe into this project and we are building everything on it. So the project was discontinued. Yeah, pretty funny. Atlantis, it's like, yeah, who knows what is it? Who use it? Nobody, right? So then another question which I probably have to ask, how do you run Terraform now? Like you have Terraform files laying around. Pipeline. So pipeline like GitLab CI, Circle CI, running Terraform apply or Terraform plan, and then you go to this pipeline and you figure out, okay, this chunk is actually a Terraform plan, and you figure out reason if it's good or bad, right? So the idea of Atlantis is that you submit pull request. Atlantis will be executed on this code which is changed, or it can be configured, but it will be executed, and it will just output plan into this pull request as a comment from certain user.
You don't have to grant access to the pipeline itself to everybody.
No, so the only thing which you have to do is you have to tell or you have to give access to Atlantis to be able to pull from your repository. So this means your code will be possible to run Terraform plan and apply without giving access to CI server, but just to Atlantis.
Okay.
It is open source project, and the guy who has actually two guys who started working on this project now working in HashiCorp. So you may think, what's the future of this project? I asked about this many times. I got pretty positive answer. So I still use Atlantis, and I see development of it is actually going on quite well. So this means that if you want to use to integrate Atlantis into your code base, there are several ways you can do this. First of all, you go to this website, and then you see how you can run it on your infrastructure. If you're using Google or AWS, there are ready-made solutions. The solution which I made is to execute Atlantis ECS service on Fargate in your account or in your infrastructure. So you can specify whether you need VPC, or it will create VPC for you, and it will create a bunch of other resources, and it will make Atlantis available for your repositories. So this means that if you already have GitHub, GitLab repositories with Terraform code, you can easily plug Atlantis into it and let everybody to go into comments and run Atlantis plan, and they will, after some 5-10 seconds, they will see exactly all this output in this pull request. So this is very important for the situations where you have to, like normally you have to ask, did you run this code? or does it work, or what does it do, like, or is it even valid code? I mean, all of these things has to be answered. Like, my vision is that many of these things has to be answered as early as possible, preferably before developer commit any code at all. So if developer commit any code, then at least this code has to be valid, documented, formatted. We don't discuss this one at all. When it is already a pull request and somebody wants my attention to it, at least this code has to be doing what we all agree. I can execute a lot of Terraform code in my head, but I don't want it, really. And as I proved today, I missed one spelling mistake. So one guy committed a pull request and there was locals instead of local, and I merged it. I mean, that's crisis. I don't want this from happening, so I'm working on running Atlantis for public repositories. One of my projects is to allow everyone to simply connect to these public Atlantis. It's a lot of interesting challenges there, but no, I have bonus actually here. Cool. So who knows what is it? Good, good. It's a pleasure to see. And this is a company which sometimes pay for my time. So this product by Cloudcraft allows to visualize and to draw diagrams and connect different components, and it's very helpful to see what kind of stuff we have created in the account or how our project is built. Some time ago I was thinking that we have AWS console, we have Cloudcraft with visual diagrams, and we have Terraform as infrastructure as code. So I started making a tool which gets visual diagrams and convert it into Terraform code, taking into account all details which were already discussed, agreed, specified, like relation between different components, meaning of this relation, type of or property of different resources, and so on. And convert it into Terraform code the way I would write it myself. So from Cloudcraft we have design, plan, and visualize, and then Terraform AWS modules is just building blocks. As I said earlier, I like to reuse code. I really like to not write new code simply because I can. I always reuse, and Terraform is infrastructure as code. So this tool is open source. Last week I made a demo video which I presented during Hashi Talks about how this all work. So this infrastructure as code generator is open source, free. Yeah, I couldn't find any more labels for free, so but I put this too. It's Python 3.6 serverless framework, open source code. If you want to see how serverless framework can be used, you can find it there. You can try it yourself. It is available for free for all Cloudcraft accounts. You don't have to pay $40 a month or something like this for the subscription of Cloudcraft in order to try it. But if you want to get an account of Cloudcraft, please send me an email and we will figure out something. And yeah, the code which is generated by modules TF is, I'm quite sure that a lot of people think like this is going to be produced code which I will just delete. I mean, I will look into this for inspiration and delete it. So that's what I didn't want people to do. I want it to be as close to something what is potentially ready to use, where you just need to specify key values which you didn't specify in the visual diagram, because not everything makes sense to be visualized, or it's not even possible to visualize it. So that's why it is potentially ready to use, and it sets structure as well for the for the project in general, and you can get a clear understanding of which kind of resources were created, how they're connected, what kind of properties are there, and so on. I also enforce Terraform best practices, which I describe terraformbestpractices.com, and yeah, several things like batteries are included there. It's open source. I didn't demo this time because I recorded this demo video. That's trick. So yeah, questions? You can take a picture of this one as well. Any questions? No. Yeah.
So you said Terraform has a lot of providers, right?
Yeah.
What's the weirdest case you've seen of a provider being used?
Hopefully not the weirdest, but I can show you. Let's see. Can you see my screen? Yeah. What is this? I don't see anything here. Is it supposed to be like this? Yeah, right. So providers. Let's see, where is it? Terraform. So yeah, okay, it's not provider, it's about resource. Think about, so what I'm showing is code of Terraform AWS S3 provider, which will, not provider, module, which will create S3 bucket. It's not exactly this one, but still I think it's relevant to your question. The point is that in Terraform 0.12, a lot of features become possible, like dynamic blocks, content, or dynamic blocks, for loops, and so on. This code looks so scary, but it's working, because in Terraform 0.11, there was no way to specify optional arguments. So that if we need to have resource where, like I showed in RDS example, MS SQL has support for time zone, but MySQL does not have this. So that's why we create these two resources and switch counts there. In order to make a module for flexible AWS S3 bucket, we need to have 15 of these properties to be switched on and off. From what I understand, it should be 15 times square number of combination, which is 225 resources with extreme count in it. And the hardest part here, even if I can automatically generate using Jinja or using Cookie Cutter all of these templates, all of these files, all of these resources, there will be a situation that when I need to, let's say, imagine situation, you create bucket, you specified some properties into it, bucket is created, and then you say, oh, by the way, now I want to enable encryption. If we have 225 resources, this means that in order to implement encryption, we need to delete previous object and create new object. So right now, this is not supported. And answering your question, how I saw some people were trying to solve this problem. So they made infrastructure module for S3 bucket. And as I said, there are many combinations, but they don't want to allow to lose information in these buckets. Because, I mean, just by enabling encryption, I don't want to lose all of my files in the bucket. That's kind of obvious, right? And what they did is that they tried to execute using null resource local exec AWS CLI, which will verify whether this bucket will be created or deleted, and change name of resource to tell Terraform that actually it's the same resource, it's just new property. So this is like one of this extreme example where people can do crazy things. I was trying to implement it on more like general scope, but the code was very messy. Really, it's not it's not nice. Terraform 0.12 allow us to do this, so yeah, it will be one of these modules which is supported. I can show you. So for AWS, since we're talking here about AWS, let's look into Azure. Azure is slightly different. They don't care about 0.11. They say that. So who cares about 0.11? They are so forward-looking. So they started to making some of this. You don't have to take picture of this, really. It's so they want people to use Terraform as well, quite obviously. They're hiring as well. If you want to apply and work with Terraform, they will be very happy. But the point is that there are so many limitations in 0.11 which people could not figure out how to make it elegant enough. So they say, oh, we will better wait for 0.12. And meanwhile, if you're working with Azure and in Terraform, have fun just by implementing your specific use case without thinking on more broad scope, simply because it will be hard. I developed one network module which is similar to VPC for Azure, and yeah, it was pretty hard. Somewhere here, anyway. So yeah, it was very different from what I get used to work with AWS. So think about like talking about providers. Many providers which are good in real life, they have good API. DigitalOcean, excellent API, very linear, no crazy blocks, like modules of, or not maps of list of list of maps, maps of list. It's not for DigitalOcean. Everything is linear. So it's very easy to work with. And you will be able to understand it just by starting working with it. With Azure, it's not so. So this is like related to providers. Yeah. Yeah, go on. You can take sit.
What is your recommendation in order to work with the state file as a team?
Yeah, so normally what we get used to do for quite some time with Terraform, I don't know, 0.6, 7, 8, at least I was doing this quite actively. We had Slack where we said, hey, don't touch this file, I'm going to work on it. Right? I mean, we still do this sometimes in some companies. I see this quite often. And then Terraform and Terragrant first, and then Terraform introduced lock-in. So in lock-in, you have possibility to tell that when I'm changing something here, or when I plan or apply, nobody else is able to run it. So in 0.11, this is very mature and works very well. The problem with working in the team is usually lay between who is going to how can we discover that I added new feature and you can use it now. Let's say I work on VPC module and I added this new routing table which you can put your rules into right now. So for this one we still have to coordinate somehow. As soon as we do this in a versioned manner, then you know that my module is pinned to a specific version, and you are using just old version. When I say that, hey, now I finished my version, or I released new version, you can check out this new one and just start using it. So other than that, there are interesting challenges which I think will be, not challenges, but interesting approaches which people are trying to implement using ChatOps. I like to be thinking about ChatOps as a way of accessing your GitHub repository from Slack. So literally what you can do is that you can write /Terraform and then show IP address or service A IP address or something like this. What it will do, it will execute some Terraform output on specific state file, and it will print you back this one. This I find quite helpful for some situations. I don't want people to create Terraform code from Slack, because it diminishes the whole purpose of Git, right? Who will commit? Slack? I don't think so. So this is pretty interesting approach. And in general, working as a team is not so rocket science anymore. You start working with your specific files, you iterate on it. Once you finish, you announce it somehow, other people pick it up and use your specific pin version to use it. In big organizations, if you establish this pattern as we work on different modules, everything is versioned and everything is logged to specific version, everything is documented, everything is executed using just Terraform apply without any crazy var file and so on, then it will be easy to pick up new knowledge or suddenly start working on other module, because you just have to be an expert in AWS specific thing. You don't have to learn Terraform every time you switch companies or switch project. That's unfortunately not true between companies. There are many different ways how different companies work with Terraform. So not everyone is using modules in this way. Many companies are structuring code very differently. So I describe some of this in Terraform best practices, what I learned, what people are doing, and how it's good or bad. Do you have specific ideas about or things related to how to work with Terraform as a team?
I guess my question was more directed into just the Terraform state file and the locking that you mentioned at the beginning. And so basically the backend, defining the backend of Terraform and locking it so two people cannot apply at the same time.
Yeah. So.
And as an example, I know a lot of providers do not have defined a backend, and in order to have that functionality, you need to define it either in AWS or using Swift for OpenStack or whatever. So that was my question. What's your recommendation in order to solve that? What's the best thing? Because maybe I don't want to have AWS accounts or OpenStack accounts. Maybe there is something that I'm missing. And
yeah. So up until recently, I was very happy and was meeting people who are using S3 and DynamoDB for state and for locking respectively. And just recently I discovered a bunch of people from Azure who are happy with Azure tools for that. So Azure has also storage account which you can configure same way as buckets. I don't think, maybe they have something for locking, but I just don't remember. But there are a bunch of different technologies depending on your preference. I'm quite certain that people who use OpenShift also have something. I just don't know it. It's probably well documented in Terraform documentation. I just don't know. Majority of people like to use whatever they have available. So it can be a console if you already have console for key values, or it can be I think what is it? Sorry?
DynamoDB.
Yeah, DynamoDB is usually like by default, even if you're not gonna to use DynamoDB as a service, but it's very easy to get started with it, and you can bootstrap your account, create bucket, create DynamoDB, and you will never ever have to look into it anyway. What is important to set up in the company, like in general when working as a team, is a bunch of naming conventions, like where state file will be stored. As far as I understand from what I experience is, majority of people are happy with following exactly the same strategy as name of the directory where we are. So it is name of account. Can you turn it off, this thing? I feel safe.